Thanks so much, Grant. I really appreciate you guys having me here today. Pretty exciting day here, especially with the Villanova win, so I'm sure there's some excited people in the audience today. So I appreciate you taking the time to come here. So as Grant said, I am Kelsey Oh. I'm a Venture and Innovation Analyst in the Office of Entrepreneurship and Innovation at the Children's Hospital of Philadelphia. So there's a lot of acronyms in all of this, but that's the CHOP spirit. So Aaron and I are going to be talking about, as Grant said, Alexa at CHOP, how we've used it so far, and some of the downfalls that we've noticed. So quick agenda, goals and requirements. I'll go over a little bit of background information for this application, and then Aaron is going to go into the technical challenges, workarounds, and things that we've learned through this process. So I figured I would start out with a little bit of background information because when I say Venture and Innovation Analyst, it's a pretty vague title, and most people, including my in-laws, have no idea what it is. So I figured I would start out with a quick background info. I started my career at Drexel University in the School of Biomedical Engineering, and as most people know in the Philly area, Drexel has a really awesome co-op program, and so my first co-op was at Princeton University at the Princeton Plasma Physics Lab. And there I did some research in electroactive polymers and their applications for artificial muscles. And so very research heavy. So I decided that I wanted to move more into industry for my next two co-ops, where I landed at Integra Life Sciences in project management. And that was where I found my love for spreadsheets and timelines and budgets and all of those fun things. So when I graduated, I decided I wanted to go, continue in the realm of medical device development in industry. So I ended up at Globus Medical in clinical research, and about a year into that, I got an offer to lead and manage the Philadelphia Pediatric Device Consortium at CHOP, which is an FDA-funded consortium aimed at developing medical devices specifically for pediatric patients. So a really awesome opportunity, really exciting things happening at CHOP and in the Philly area for pediatric device development. And so about a year and a half into that, the Office of Entrepreneurship and Innovation opened up. And it was really an opportunity to expand my knowledge from my traditional medical device development kind of understanding to a broader scale of software, apps, really the whole healthcare innovation paradigm. So what is OEI? We are essentially an internal resource for CHOP, both clinical and non-clinical. And we're really a place for people at CHOP to bring their cool ideas. So everything from, I've been doing this research in the lab for 30 years to, I thought about this 30 minutes ago when I was doing rounds on the floor. We're really a place for people to bring their cool ideas and have them realized. We do de-risk things, challenge key assumptions, and in some cases build, which is what I'm here to talk about today with you guys. We are stage agnostic, so as I said, something that could be, pretty well developed to things that are brand new. And also, I say solution agnostic. So it could be an app, it could be a software, it could be a device, consumer product, or a spin-out company. So just some quick examples of those on the slides. And a little bit about the CHOP SDU. So it stands for Special Delivery Unit. So as I said, a lot of acronyms thrown around here today. It was the first birthing unit dedicated specifically to mothers delivering babies with known birth defects. So this is where families would come if they know that their baby is going to be born with a birth defect, to make sure that the best clinicians are there to obviously stabilize their kid when they're being born. And so we've been around for about 10 years now, delivered about 3,500 babies and counting, and we get cases from really all over the world. All 50 states, 50 plus countries. It's really an incredible team effort, as you can see in the image there. There's a lot of people that are involved in this. We have neonatologists, we have fetal surgeons, respiratory therapy, nursing. It's really the whole gamut come together to really make sure that this baby is okay and stable. So every delivery is high risk. So since these are babies with known birth defects, these are babies that need extra attention when they're born. It's important to note that while birth defects as a whole are not uncommon, there are some birth defects that are more common than others and more prevalent. And so a clinician could see, 1 or 2 cases a year in some birth defects, or 1 or 2 cases in their whole, practicing life. So there's really a gradient to the frequency of a lot of these birth defects. So how do clinicians keep up to date with all of their information and really make sure that they're practicing as well as they can? There's a variety of sources, both print, journals, peer-reviewed articles. We also have at CHOP what we call optimal care guidelines. And that's essentially best practices, that we learn over time. And then also national consortia that come together. A lot of the larger children's hospitals come together and kind of agree on certain best practices. And so those become things like the Neonatal Resuscitation Program, or NRP. It's important to also note that a lot of this information is critical to know at the time of care. So you don't have time to, in the middle of delivery, run back to your desk and say, let me Google this really quick. You need to sort of know it on the fly. And it's a lot of intricate details in some cases. So why do we need to change this process? The reality is that the application of a lot of the guidelines and a lot of the things that we rely on every day aren't being applied very well. And so as you can see in the image on the left there, a lot of the commonly used charts and commonly used equipment, sometimes we just take pictures and we throw it on the wall. Obviously, this is not ideal. You can see there's one that looks like it's about to fall off the wall. And so the reality is that this could fall off. Someone could come in and accidentally throw it out, and that information is lost. And we don't realize that it's gone until we need it, which is too late. We also sometimes, clinicians who, let's say they had a specific, they saw a certain birth defect 2 weeks ago and they learned something throughout that process, there's really no way for them to share that knowledge with anyone else right now. So sometimes they'll text their colleague and say, hey, I know that you have a baby that's going to be delivering soon with this birth defect. I had this 2 weeks ago. This is what I learned. Don't forget to do X, Y, and Z. So obviously this is not ideal. So there's a lot of information, and just really the application of it is not optimized. And kind of secondarily, there's also a missed opportunity for education. So with CHOP being a teaching hospital, it's not ideal to have this as really our way for teaching, younger clinicians coming in. So we then settled on this Alexa project. So the SDU clinicians came to us and said, we need something to change here. And we said, well, first step for us, first goal is to aggregate all this content. How are we going to get all this information together in one spot so that way we can access it at the time of care? The second step was to build a system to actually access that content. So the first idea was actually to use a phone app. But the reality is that if you're, interacting with a patient, you don't want to pull out your phone and have to scroll through content. So we wanted it to be easily accessible at the time of care, I guess optimally hands-free or low touch. Be up to date. So we wanted one single source of truth as opposed to, this journal saying one thing and this document on someone's computer saying something else and information in someone else's head saying something different. So we wanted that one single source of truth. And then obviously the third is secure. So, being a CHOP, we obviously need a high level of security. And then the third goal is that we wanted to test this change. So that's something that within OEI we like to do. We do really quick iterative testing. And so we wanted to have really one use case where we could test it out, see how it goes, and then learn from there. So we partnered with the CHOP Sim Center to do this type of testing. So now I will hand it over to Aaron to talk about some of the technical challenges and workarounds and things that, to be honest with you, I'm not too great at.
So these are the things I'm going to talk a little bit about in the second part of the presentation here. How we went about implementing the Alexa skill, how we went about connecting it to a screen so that it could display all this information in the room for the clinicians. One of the challenges we faced is making Alexa spontaneously alert the room when a certain amount of time had passed. We had problems when the doctors decided, rather than saying, please go to link 3 on the screen or please go to the 4th item, they wanted to navigate by name. We had some challenges actually figuring out what content to fit on the screen to make it usable in the room, and then actually getting Alexa to understand the commands we were trying to give in this crowded room with medical terminology and things like that. So when we went about implementing this skill, we found that there are two options you have to build an Alexa skill. One is to build it yourself, build your own back-end server that will handle requests from Amazon when a person speaks to Alexa. And the other option was to use Amazon Web Services Lambdas, which are sort of a canned runtime environment for little pieces of logic. And we went with the second, with Lambdas, mainly because it's free and because there's no particular effort to connect it up to Alexa and make sure it's handling requests properly and things like that. Those were really important concerns because we wanted to just get this together quickly and get it in front of some of these doctors and get their feedback and iterate on it. We didn't want to spend a lot of time on kind of technical infrastructure. The one concern we had is that according to the documentation, if your logic takes too long to run, then Alexa will just time out and say, oops, didn't work. And we didn't really want a doctor to be in the room asking a question of this device and then it times out because our Lambda didn't run that fast. It turns out that hasn't been a problem in practice. There can be problems with execution times with Lambdas, but I guess Amazon has made it work so that Alexa doesn't have an issue with that. So that was good. So we were pretty pleased with going with a Lambda, but the first choice we had when we went with the Lambda is then to decide what programming language to use because it supports like 6 of them: Java, Python, C#, I think, Node. We went with Node for a couple of reasons. One, we were going to build the user interface for the screen in JavaScript, and so it would be easier if there was only really one language involved. Then we would also end up ultimately sharing some configuration data and things between the front end and the back end, and it helped again that they were both in the same language and we could literally share files and logic. Also, it turns out that Lambdas execute faster in JavaScript or in Python, so it was a good choice for that reason as well. So in the end, I think we were pretty pleased with that decision. The one challenge was right at the time we started building this, Amazon was transitioning from one JavaScript and Node SDK to a new one. The good news was the new one was much better. The bad news was all the documentation was like half pointing to this and half pointing to that. So it was a bit of a struggle to figure out how all the moving parts needed to work. But we were pleased with the improvement they made in this new Alexa Skills Kit for JavaScript, or sorry, the Alexa Skills Kit SDK, replacing the other one. I don't know how you tell those two apart, but. So the nice things about the current Node SDK are that it's very easy to model a state machine, and that's kind of what we had. At any given time you were on one screen, and based on what screen you were on, you had different options to go to other screens. And then you could transition to another screen, and then you had different options from there. So it kind of was a state machine, and it was a good fit for this library. Now, one of the things it lets you do is both hard code the states in this state machine and add new ones at runtime. And we ended up taking advantage of that so that as we worked with different conditions or birth defects that the doctors were going to treat, we could build different procedure definitions, and those could then flow into the structure of the state machine. And that turned out to be a very good way to navigate and to handle the different voice commands you could give at any given position in the app. The one challenge with that is as we were iterating on this application and the functionality, and as people would try it out and some of the requirements would change, the screens and states would change, and then we'd have to go back. I mean, I guess it's kind of unavoidable. It doesn't matter which technology you pick. But the closer you are to have an accurate idea of the available states and the transitions, or in our case, the screens and the transitions, the better an idea of that you have, the better the chances that everything's going to, you're going to build it in the right way and it's going to work well as you move forward. So we did struggle a little with changing requirements. I'm sure everyone in the room is probably familiar with that. But I think all these decisions were good ones. We were happy with Lambda. We were happy with Node. We were happy with the new SDK. So that was kind of a good news part of the process. Now, in terms of the nuts and bolts, like it's kind of weird that you're working in Amazon Web Services for Amazon Alexa, yet you have to use two completely different interfaces to manage these things. AWS is separate from the Amazon developer, so you end up using two different web consoles. One of them has a command line tool, the other doesn't. It's a little unfortunate. So I think Amazon has some opportunities for improvement there, right? They could make this a little easier if you could use one set of tools and one website to manage this all. And then, the first time you sit down in front of an Alexa skill and try to define what commands are you allowed to give, what are the go through some testing, look at the logging and debugging output. It's tough. It's a lot to wrap your head around. But then, once you're up and running, I think the ongoing development process and changing and iterating is more straightforward. One of the nice things about the way they've set it up is you can have different versions of your backend Lambda function exposed to different Alexa skills. So you could have one development skill where the developers see the very cutting edge stuff, and one skill that you only share with testers that's on a frozen version of the Lambda function. So you can keep developing new features without breaking the version of the Lambda function that your testers are seeing. So that was pretty convenient. So again, there were some wrinkles there. I think again, Amazon could improve some things, but overall, we were happy with this decision. Now, as I mentioned, the testing was an issue. There are a couple different ways you can test. One is you can go to the web console in the browser for Alexa, and you can type in commands as if a person said them. And then you can see how the command will be submitted to the backend Lambda. It will emit a response, and then it'll display that response on the screen. It won't speak it to you, but you will see that, that Alexa was directed to say, these words. And, that's very convenient for rapidly testing. You don't need a device. You don't need to talk to a device. There's no chance that Alexa is going to hear the wrong thing because you're typing in exactly the words that you want her to process. But it does not represent the real world, right? As we'll talk about later, she does hear the wrong thing. There is confusion when there are too many voices in the room. So this is good for making sure your logic is correct, but it doesn't necessarily mean that the skill is going to work in the real world. So then you also have to do voice testing where people, and especially different people, try out an actual device. It can be like an Echo device. It could be a headset that supports Alexa. There's a different website, echosim.io, where you can actually hold down your spacebar and speak into a laptop, and it will process that as if it was an Echo or an Alexa device. So those kind of things are good for voice testing, and that's how we turned up some of the places where, there were more rough edges in what she heard, or, how she handled particular voice commands. So, I think you need a combination of both of those. And then there's also an Alexa app for your phone that can show you what Alexa claims she heard. But it turns out that's not always exactly the same as what gets sent to your backend, to your Lambda function in our case. So we also had to watch the logs produced by the Lambda function, which went to AWS CloudWatch. And so with that, we could log exactly what was getting sent to our Lambda function compared to what somebody said. So, at different times, we ended up with a big spreadsheet saying, give these commands. Okay, this person, this is what we saw. When this person said it, this is what you saw. And trying to handle exactly what some of these different things were that she heard. So this was kind of our test suite, right? We had, the manual testing just to make sure our logic was correct in the browser. We had voice testing to make sure that she was going to be responding appropriately through an actual device or voice interface. And then we had these backend logs we were scraping to see, to make sure we were accurately accounting for what was sent to our backend for the different voice commands. So the next challenge then was connecting Alexa to the screen, because what we wanted was a large screen, like a television, in the SDU delivery room that would show the important information for the clinicians. So if they're telling Alexa, please show me a diagram of the infant's heart when they have this particular condition, we want to show that on a big television that they can just look at. We don't want Alexa to say, well, the artery is going this place, whereas the vein is going that place, right? It would take forever for her to try to speak through something, and it's one of those cases where a picture is worth 1,000 words. We also wanted to be able to show some vital statistics, as the time is passing, these are the target thresholds that you should be aiming for this child with this condition. You want to make sure these statistics are at these values. If not, you need to be escalating your care, taking more aggressive steps. If you reach a certain point, then congratulations, you're basically done. The baby's safe. We can put phone numbers there. If things are not going well, call the cardiac ICU at this phone number or whatever. So for all these reasons, we wanted to have an app on the screen that was coordinated with Alexa. So you speak to Alexa, the right content comes up on the screen. Amazon has this device, the Echo Show, that includes a screen, but it's a little screen. And if you remember back to the picture of the room, this is a room that's got 10 people standing in it. If I have a screen like this, you're not going to be able to read it from the back of the room or whatever. So the way we approach this is to actually put a television in the room and have a mini PC using that television as a monitor, and then running a full screen web browser. So we were basically building a website or a web application, and the output of that was what was showing on the screen. So then our challenge is, how does the Lambda function, the Alexa backend, talk to this app running on the television screen? So we need that coordination in place, and then it should work, right? If you talk to Alexa and she can send some kind of command to the browser, it can bring up new content. That's what we need. So the challenge with that is the Lambda has no state. When you run an AWS Lambda, your logic may stay in a running machine for 5 minutes or 10 minutes or 15 minutes, or it may be killed at any time. And then the next time a request comes in, it gets spun up again. So that's very efficient. I guess that's part of how Amazon doesn't need to charge us for this service. They can shut down things that aren't being used and spin up the ones that are being used more, and they can be pretty efficient about it. But it means, if you save something in a variable or to the file system, it could be gone the next request you handle. Or, if it goes the other way, if usage is going up, it may spin up multiple instances. So something stored over here might not be accessed to the next request if it's running on a parallel machine. So the web app, on the other hand, has state. You can stay running the same web app on the same computer on that same screen, for days and days. So, the question is how to bridge that gap. To maintain state within the Lambda function, what we wanted to do is have it store its state in a database, basically. So every time it starts up, it can connect to that database, find out what its state is, and move on. So what we were looking for is some kind of identifier to say which Echo device is this, or which Alexa instance is this. So it could use that identifier to look in a database and say, what is the current state for this device, and pull that out and then act accordingly. So there are several options for this within the Amazon sphere. The Amazon Alexa Node SDK has DynamoDB handling right out of the box. So it's like you set a variable and you're done. It'll store its state in DynamoDB, the Amazon NoSQL database. But as it turns out, that didn't have all the features we were looking for. So the question is then, what are we going to do for this? And what we came across is Firebase, which is the Google NoSQL database. And the really interesting part of Firebase is that you can watch a record and automatically get notifications when that record is updated across the web. So we could have our web app running in the, on this screen on the wall, watching a record in Firebase, and when Alexa pokes it, then instantly the web app sees the update. So Alexa can say, I'm on this page now, and the web app can say, oop, page changed, and it can show the new page, the new content. So that was fantastic. We didn't have to worry about connecting and reconnecting and handling firewalls and timeouts or anything like that. All we did is kind of say, let's connect to Firebase, and boom, we're done. So that was wonderful. Now the screen would generate a unique ID for itself and store it in the browser's local storage. The Echo device would have an ID for itself. So when the app started up, the screen would come up not connected to anything and just display its 6-digit code. And then there was a setup process for the Alexa app where you'd say, connect to screen 169423. And then they were tied to each other. They would each have a record in Firebase pointing to the other one, so each one knew what it was supposed to be watching, and then they would watch these records, so as updates were written, they'd stay in sync. So Firebase worked really well for that. On the other hand, this means we have, this Lambda running in AWS, talking to a database in Google, and we're really concerned about performance, because if it takes too long to run, then, Alexa might say, sorry, your skill didn't work. Plus, now there's a security issue. So you've got content in 2 different data centers. If you want to have Firebase authentication, then this Amazon Lambda has to authenticate to Firebase, and you have to coordinate that. And so maybe every time the Lambda starts up, it needs to read saved Firebase credentials somehow. You know, you've got to be able to tolerate this delay when your calls jump from one data center to another and back before you can then send the information to the web server and get back to the user saying, okay, I heard that. There's another point of failure. I mean, you could go on for a while. It's not an ideal architecture, right? You know, because CHOP information is being stored here, it's not personally identifiable patient information. We don't know what the baby's temperature is, but you know, it's proprietary. This is CHOP's best practices that they've worked hard to establish, and you know, they may or may not want to share that. They have a right to keep it private if they'd like. So you know, that was kind of a challenge. So you know, we did a quick look at, well, let's imagine that we're going to get rid of Firebase, and it didn't look very good. So Amazon has the simple notification service, but there's no browser client for that. They have simple queuing service, which has a browser client for that, but it's tricky to set up a secure connection when you have these devices and screens that might be coming and going. There are open source libraries that you know can piece together some of these things. Reuters open source one when they went through this. You know, it's there. I wouldn't say it's very straightforward. It's certainly not like the one-liner to get Firebase running. And then, you know, all that kind of setup you have to do to connect these things together is still separate from how you're actually storing the data. So there would have to be a database, and then when you change that database, you would also have to emit a notification that would then go to the browser and things like that. So, you know, we in this proof of concept, we stuck with Firebase. I think, you know, if this goes forward and becomes a real product, probably we would want to look at some of these alternatives to keep everything within the Amazonosphere. But, you know, there's going to be some work there, unfortunately. So one of the other aspects is, you know, this application is dealing with these procedures or these conditions of, you know, of the babies. And you know, those are things like that. They define things like the thresholds for certain vital statistics, the different content available for the procedure, you know, what you want to inform all the people in the room of before they start, so the kind of getting started procedures. So we made those into a shared definition that could be used both by the front end and the back end. So they could share what's the list of screens, you know, what are the titles of each screen, and you know, where can you navigate to from each screen and things like that. So, you know, they may be not, I wouldn't say everything is used by both sides, but like the title, you know, the browser may show the title in a field on the screen, so it shows you what screen you're on or what content you're viewing. And Alexa may speak that title. She may say, okay, I'm going to the phone numbers page now, or something like that. So it was nice to be able to define that in a JSON or JavaScript file and include it in both the Alexa skill and the web app. So that was one of the benefits of using that same language on both sides. But that means someone had to write it and deploy it with these applications. So as you start deploying this kind of thing to more procedures, I think that would get migrated to the database. And there would be some kind of administrative UI to set up new procedures and things like that. We just kind of didn't get that far over the course of this proof of concept because, again, we were trying to limit the scope to be able to really iterate on this quickly. So one of the other requirements that was a bit of a challenge is that Alexa should tell you every 5 minutes. Alexa should speak up and say, it's been 5 minutes. It's been 10 minutes. And one of the reasons is some of these key vital statistic thresholds are defined at 5-minute intervals. And what we were told in talking to the clinicians is if you have a good nurse in the room, they will announce every 5 minutes. But there are times when everybody's attention is on the baby. And at that point, you know, people may not notice the passing time as well and may not look up again until it's been 6.5 minutes. And at that point, you don't really know whether their 5-minute statistic was on track or not. So they wanted Alexa to be able to say it's been 5 minutes. You know, are your vital signs within the desired range? But Alexa can only speak when she's spoken to. You know, if you have an Alexa, you may have noticed she doesn't just pop up in the middle of the day and say, hey, would you like a, you know, a such and such cookie, or can I order you a Coca-Cola, or, you know, it's time to go to work, can I summon an Uber, you know. You can imagine how obnoxious that would be if she did it, which I guess is why she can't. You know, it was a challenge for us. So the way we went about getting around this is, it happens that in this room we have a computer attached to a television. That television has speakers, and the computer can then use the television as its audio output. So we kind of faked it out. We knew what she was supposed to say ahead of time. We knew she was supposed to say, it's been 5 minutes, it's been 10 minutes. And through the Alexa developer console, you can generate an audio recording of her saying anything you want. So you can go in, and there's a little text area where you type some text and hit play, and it will, you know, then through your browser play back whatever you said. And if you're clever in your developer tools in your browser, you can decode the actual WAV file that Amazon sent to your browser to play that back, and you can, you know, save that file and then be able to play it back yourself later. So that's what we did. The computer with the web browser had some WAV files as well that it could play back, you know, when these alerts came up. Now, what that means is you're speaking to Alexa and she's answering you, you know, if Alexa's over here, and suddenly the television on the other side of the room says, it's been 5 minutes. Well, it uses her voice. No one complained. You know, that part worked well enough. But the trick here is the Lambda can't operate that timer, because the Lambda could get killed off at any moment and then be, you know, not running at the time the timer is supposed to execute. So we had to put the timer logic into the web app. On the other hand, we need that shared state to reflect when a timer has expired. So if you say to Alexa, yes, she knows that you're answering a timer prompt, are the vital signs in range for 5 minutes, and not that you're staring at the previous screen and just saying yes, you know, to nothing in particular. So that means, you know, we have to communicate in both directions. Generally, the Lambda function and the Alexa logic is sending things to the browser. But in the particular case of timers, because they have to execute on the browser side, that has to send some information back. So that was the one place in this app that had to send information the other way, and that meant we needed this bi-directional system. So again, Firebase works well for that, but it was, you know, one of those wrinkles that we didn't anticipate going in. So, you know, again, what we did initially was to say, okay, the web app, when the timer goes off, is just going to update Firebase. Now, it turned out later it was convenient to actually set it up so that the web app could call the same Lambda function, and it would do it by an HTTP request. So that meant putting something in AWS API gateway to give an HTTP interface to this same Lambda logic. And as long as it sent, the body of that request was a JSON file structured as if, you know, in the same manner that the Alexa backend would structure it. You know, the request would look pretty much the same to the Lambda function, whether it was coming from the browser or whether it was coming from, you know, a regular Alexa voice command. So we ended up having kind of two ways to send commands into this Lambda function, either through API gateway over HTTP or just from the regular Alexa voice processing logic. So that wasn't really mandatory, but it helped us out in some other areas kind of on the side. So that was what we ultimately ended up doing for this bi-directional communication. Now, this was one of the things we struggled with most. Alexa can handle things like the name of albums and bands, mostly. I mean, she gets my kids wrong all the time, but mostly she understands that. She can understand cities. She has no idea what a balloon septostomy is. She doesn't know that's a thing. So, you know, at first we had the content screens would say things, would show three little thumbnails, you know, labeled, you know, related item 1, related item 2, related item 3, and you could say go to related item 2, and she'd do that, and that was fine. You know, it was kind of hard-coded regular English words that we could handle. But the clinicians tried that out a couple times and said, no, that's not how we want it to work. We want to be able to say, go to TGA balloon septostomy, or go to CS to resection. Oh, that was a challenge. So, what we went to do then was kind of parameterize the Alexa commands, what you can do. So Alexa, display, blah, 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 using chat. Well, you can make that thing in the middle of parameter, and you can give her a list of all the valid values for that parameter. So, we had this big list. You can say balloon septostomy. You can say CS to resection. You can say phone numbers. We gave her this list of things. And she pretty much ignores that list of things. She will just pick any old thing that sounds vaguely like what you said, not even that much really like what you said, and give it back to you. So that was a big challenge. So for example, CS to resection, what she might hear. C, Esther, a section. Spicy tourist, Estevez. CS, Taurus, like a Ford, I guess. Siesta, have a vacation in your car. CSRS, reception. Seals, researching, transaction. Like, it was ridiculous. So we ended up, having as many people as we could, walk through this list of terms and pronounce them and check the back end. And we ended up encoding it into these regular expressions that look like that. I mean, it was horrible, right? For these different terms. It was absurd, the different number of things she could hear. And, we had a contact at Amazon, and they said, well, yeah, why don't you give us the medical terms, and maybe we can figure it out. That never went anywhere. So, if we had $1 million, what we would do is set up a machine learning algorithm that would churn through all of these and, have 1,000 people speak them or 1 million people speak them, and it would be really good at deducing, exactly what you meant based on what you heard. If Amazon had an API where they could give us phonemes or something like that, we'd have a better chance at processing them. But, that wasn't our reality. So we ended up with these giant regular expressions. They were pretty horrible. On the upside, every time she got something wrong, we could check the back-end CloudWatch logs and say, oh, she heard it as that this time. And then we could update our regular expressions, and then next time it would work better. So it kept improving. On the downside, there's no way we're going to cover every possibility. Her voice was different than mine. If I went through the same list with my kids in the room, it came out much different than if I did it in my silent office at work. If you're facing away from Alexa, she hears differently than if you're facing at her. There are just a lot of different conditions. So our experience is that she's just not perfect. She can get pretty good as long as you're conscious to, kind of face her and not be too far away or at least project. But she's never perfect. So, the more you train, the more time you spend on training, the better you can make it. Again, I'm not sure regular expressions are the world's greatest approach, but, it worked well enough for our purposes now. And, maybe we look at some other alternatives moving forward. One of the other challenges once we got past that is preparing the content for the screen. The first revision of this, we got screens from the doctors with everything they wanted to know. And so, there were 5 blocks on the screen, each of which had 4 bullet points, and there was a ton of information. And you look at that screen and say, wow, I know everything I need to know about this condition. But then, we got it in a room with 10 clinicians, and, they're like going mad trying to stabilize this baby, and they kind of glance up and glance away. And you can see what's going through their mind, like, look, way too much information for me to understand. Forget it. So, as we went through some iterations of this, we ended up cutting down and cutting down and cutting down and trying to emphasize the stuff that was really important. And, it was easier to present information at the beginning before the baby was born, when everyone first comes into the room because they know the birth is going to be coming soon. Then you can give them a big list of bullet points and they can kind of go through it at their leisure. They can have someone talk through it or whatever. But once the baby is there, forget about it. So we ended up with a screen more like this, which is still kind of busy, but it has the clock since the baby's been born, which is an important piece of information, big and obvious. It has a vital statistic target, which we keep updating by minute. This is one of those things that used to be posted on the wall. They would have a chart on the wall. And furthermore, that chart on the wall was for a normal baby, so it actually, the values were different for babies with these conditions. So this one is specialized to the procedure you're doing, the condition that the baby has. We repeat the next major goal right here. This is a percentage of that statistic there. Down here in red, we have if things are not going well, then you need to escalate your handling and make a phone call. And here's the phone number right here. And then we have a bunch of white space in the middle. Now, over on the right side, there's a bunch of library content you can access, specific screens you can go to. But generally, that's not needed unless you're looking for something. So the important things are at the very top of the screen in this blue, and the very bottom of the screen in red. And then there's a lot of white space in the middle. And that was what we landed at after iterating and iterating and iterating. Some of the screens have more information. I mean, this isn't, they're not all literally the sea of white space. If you escalate, there's a little bit more information there. But again, the person whose hands are on the baby is not going to be reading that. But there are a lot of people in the room. So one of the nurses in the back of the room, whose job it is to just kind of monitor things and make sure nothing is missed, can be looking at some of that information and bring things up if they're needed. Oh, make sure you, or one of the things the nurse has commented out about is if they see some of those things on the screen, then the nurse knows what's coming. And they can be going and preparing some medication that the doctor hasn't asked for yet, but the screen says that's probably coming. The screens aren't necessarily built for every person in the room to fully digest, but they're there for the key points at a glance. That clock is in very large letters. The targets are big and at the top of the screen, so you can look up and see if you're on target, and then someone might go through and handle some of these things in a little more detail. Now, one of the next challenges we faced was the actually giving commands to interact with the Alexa. I mean, I talked about how there were some problems in how she hears certain commands, but it's not just how she hears them, it's how you have to phrase them. If you walk into the room and you say, start procedure, nothing happens. You say, start procedure TGA, nothing happens. Start procedure of the, you're getting frustrated, right? Start procedure transposition of the great arteries, nothing happens. It's because you didn't say Alexa. All right, Alexa, start procedure TGA. It still doesn't work because you have to say, Alexa, start procedure TGA using CHOP. You have to identify Alexa that you're talking to the device, and you have to identify the skill that you want her to use to process that. So you can say, Alexa, tell CHOP to start procedure, or you can say, Alexa, start procedure using CHOP, or Alexa, ask CHOP to start. There are a couple ways you can say it, but you have to get all these pieces in. So, I think this might be another piece of paper on the wall. Always say, Alexa, blah, 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 using CHOP, right? Maybe we'll hang that off the television. And I think once people have done it a few times, it'll be more of a natural sort of thing. But the first time people get in the room, there was a lot of people forgetting one part or the other. And fortunately, you got a group of 10 people, so someone will say, "You forgot to say Alexa," and then the person will repeat it, and then it'll work. But if you look at the Alexa guidance, they say, when you're naming your skill, it has to be multiple words, unless it's your trademarked one-word item. And the more words you add, the more cumbersome it's going to get. I mean, this project was called CHOP Critical Knowledge, and so the first reaction was, well, we should have that in the name. Alexa, start procedure using CHOP Critical Knowledge. Okay, try to say, Alexa, next page using CHOP Critical Knowledge. Alexa, open blah, blah, blah using CHOP. You'd want to strangle yourself. So the other problem is if she doesn't hear you quite right, you have to repeat all that. So the more that's there, the more cumbersome it gets. And one of the things we saw in the room is if a doctor or a nurse is speaking to Alexa and she doesn't hear them right once, they might repeat it. If she doesn't hear them right twice, then they're done with that. They're not going to spend any more attention on this device while there's a baby there. So, it was important to try to give them the right guidance on what they need to say, to have Alexa respond appropriately. I mean, absolutely the worst case is she thinks you asked for a video, and then she'll say, she has a big canned speech about, I don't have something installed that can handle playing back this, but if you go to the Audible bookstore, blah, 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 and you're like, Alexa, shut up! So, you know, there was some massaging to get the right commands. We discovered you can't use the word stop. So you can say Alexa end procedure, but you can't say stop procedure because stop is a magic word for her. You know, she's all over that stop and she doesn't hear anything else. So, you know, this I think is one of the areas that Amazon can fix that we can't really fix. Like we can't make it work better if every time you have to say Alexa, you have to say using CHOP. You know, we would really like Amazon to allow you to say, I'm going to lock this Echo device to only this one skill. So you don't have to say the skill name. It's only ever going to run the CHOP skill. Everything you say to her, imagine there's a using CHOP on that. Now, Amazon has come out with a business program, and that's not yet one of the features, but you know, we can all knock on their door and tell them we would like it to be. So, you know, one of the things we found in practice is it's best to have someone who's kind of responsible for interacting with Alexa. One of the nurses who's doesn't have their hands on the baby. You know, there are enough people in the room that someone can do this. This is the person who'd be looking stuff up on their phone, you know, if they didn't have this app. So it's not, you know, it's not such an onerous new requirement. But, you know, you don't want them to be on the wrong side of the room from Alexa or facing away or unable to be distracted. And so, you know, someone, again, who doesn't have their hands on the baby, who isn't being called on critical things at the moment. And we hope that this Alexa for Business program will give us some of these features down the road to you know, identify a default skill for a device or lock the device down to only one skill. One of the things it did give you is you can tie the device in the room to a particular television out of the box if you want to. You know, it understands about devices in rooms. You know, I think they have conference rooms in mind, not delivery rooms, but it, you know, it works well enough. So, you know, we hope that Amazon can tweak some of these things moving forward. In the meantime, we're kind of doing the best we can with what we have, with the workarounds we found. And, you know, in reality, it worked pretty well. I think everyone walked out of the room saying, gee, I wish I didn't have to say using CHOP every time. You know, it wasn't perfect. But you could navigate by voice. There were very few times where it completely fell apart. So that was pretty good. The last problem we ran into, though, is you know, because you have to say these things, we put that advice on the screen. You know, we would have the text in a special blue color with a special icon was the things you could say, and we would put tell CHOP to in front of the command. So you would say, Alexa, tell CHOP to you know, display CS to resection, or Alexa, tell CHOP to start timer. So we put tell CHOP to on the screen, and then one day she couldn't understand tell CHOP to. You know, it was, every time you said that, she would either just fail or completely misinterpret it and not call our skill at all. The next day, it worked fine. So the bad day, it still worked if you said ask CHOP to, or if you said blah, blah, blah using CHOP. But all our screens said you were supposed to say tell CHOP to. So it seems like, you know, it was just like Amazon was tweaking their algorithms that day. You know, they made some change, they discovered it was a disaster, they rolled it back, I don't know, or they just made it worse and then made it better again. But that's, I guess, one of the things to be aware of. Like, in reality, we would want some kind of administrative tool to toggle those hints on the screen. So if one day tell CHOP to didn't work, you could just go into the admin interface and, you know, switch it to ask CHOP to, or switch it to using CHOP or something. Because that was the day when it was really kind of bad in the room, when things weren't working, and, you know, people would repeat themselves twice and then forget about it, and, you know, 10 minutes later someone would go in and try to clean up, or they would just leave it altogether. So, you know, that's the kind of thing to avoid at all costs. All right, well, I think we're about at the end of our time, but we'll be here for a few more minutes if you guys want to come up and chat or whatever. All right, thank you.